Bro, I'm not even allowed to leave the house.
Yeah.
I mean, only for like school and actually get farther.
All right, and there's some folks there already this morning. Good. Good morning, everybody. We're going to work more on our electromagnetic experiments today. But let me first take roll of folks that are at home, and I already got a bunch of them. Thank you, folks at home, for showing up. So today's 12th, short week. It's sort of like Friday, except it's Wednesday. And I've got Malta. I've got Kiara. I got Linus. And I've got Julius already. That is really good. And folks at home, we're going to work on this. So you may want to locate that file, or if you ran a copy, you can find that this morning as well. Everybody else here, you can find your lab that we're working on. I'm going to go get the cart. Oh, and I got Lauren here too. Good morning, Lauren. Thanks for checking in. And to the cart I go.
Yeah.
Wait, this is the LiveStream, right?
Yeah. Yeah. Thinking about LiveStream is that they can hear us, but we can't hear them. So I think they can still hear us.
I kind of want to go up and say hello.
No, but we can't hear them. Yeah, we can't hear them.
Malta, unclap your cheeks.
You know they can't really hear us. It's like really garbled. Microphone. I listened to it again and I just started like being back on the oh,
Yeah, just pronunciate like words really clearly and loud.
just speak backwards.
Is this articulate and loud enough? We'll find out later.
I think you have to like actually go up to it. Anyway. Why did I put it everywhere?
Okay, anybody else? Yes, Charlotte is there. Good morning. Write Charlotte down. Just a couple more and we are complete. Okay, let's get this hooked up. Two extension cables. And we'll start. All right. Oh boy, that's so complicated. Everybody's tech life this complicated at home. Plugging and unplugging everything. I hope not. Whew. Okay, let's move these folks over so they can see the board better. And I'll try and arrange the demos so everybody can see those too, both here and there. Oh, but I got something else too. So my people, I'll tell folks at home as well. I talked to Miss Crow. So I've got the results of the Stanford test that you took in 8th grade. You took a set of tests in 8th grade called the Stanford test.
What?
At any rate, so you get the results now, along with this. And actually, could I ask you, Stella, to give everybody one of those? That goes to your parents. And she says, be sure and tell students, don't get all upset whether it's good or bad or whatever. If you have questions about the results, you can email Ms. Crow, or your parents can email her or call her as well, okay? So that's kind of what the sheet probably says that Stella is passing out to you now. Folks at home, you'll get these next week when I see you. So be not alarmed. And I see in here, Abram, I've got your brothers, and I bet they put your brothers in the other room. I'll go over there and see if they've got it. See if they've got yours, okay? Okay, but others I'll pass out over here. I know it's been a while. There it is. There's him. There's Ingrid. There's Troy. There's Jake. There's Troy. I think that's it. Now you've got,
I don't care about this.
oh, well, then that's fine. Okay, well, let's see. All right, let me see if I can get out of here.
Close the bar. I don't know what this one is. This part up here is like the, what's the percentile band? Does that like mean where people are? Or does that mean? Apparently I'm high. No, I'm middle. What's the national percentile band? It says rock practice.
Okay.
One above average.
Okay, so my advice is, as my parents used to say, take it with a grain of salt. In other words, don't really worry about it much, all right? You're in 8th grade. You got a lot of developing to do, whether it's good or bad or whatever last year. Don't sweat it too much. Good. Let's get this chair out of the way. And let's review something. Folks at home can review with me too. You ready? Here's my review question. Well, somebody raised it pretty badly. Is that me? No. Oh, man, that's terrible. Freaking A. How can I get that off? Somebody got a blowtorch? What did they use on here? Okay. Piece of rock from somewhere? Oh, man. Can you tell whoever this was not to use that green again? That must be a green from planet Mars. Oh, man. Usually it's, if anything, alcohol, ethanol will do it, but I don't have any with me. Generally, these are not water soluble. Ah, caramba. Okay. So here's my review question. What do we need for the Lorentz force to occur? So we need three things. What do we need for the Lorentz force, or the all right, and it folks at home too. So what three things do we need for the Lorentz force to occur? Okay, while they type, I'll take one from somebody up here. How about start us off, Corey? Again? Force. Yeah, it is a force, so I'm sort of saying, what do we need to make that force happen? So, okay, got one from Kiara, and it is flowing current. Good, flowing current in metal. And that could be like a lead or it could be whatever. Okay? Ingrid, give me another. Yeah. Good. And then the third thing I need is kind of what? See if you can think of how to describe it. Or think of what we did sort of to make the force. We had current, we had a magnetic field, and we kind of have a third thing too. What about that? What do you think?
So you did like push and pull the electron.
Good. I got to push or pull something. And physically, what did I push or pull in my demos?
Use the well.
Or what was pushed or pulled?
Well, you use the lead in one of them.
Okay, the lead I pushed or pulled in one. Good. And then a magnet. Yeah. Let's see if someone has described it here. Yeah. Zach, you're on my side. Let's start with a force. That moves something. And what how about we say moves the one of the things we said here was the metal. In the magnetic field. So I think we had movement each time, we had flowing current, and we had a magnetic field. And I know there's not four things, but I'll just add this. All right. These need to be at from each other. Each other. So let's say something can fill it. So these need to be at from each other. Okay. Right angles, good. Can I write 90 degrees because I didn't leave enough room for right angles? But that would work. Or perpendicular, you can say. Super. Oh, and Timothy Padusel is there a little late, but yes, okay. Oh, you were there. Yeah, you got to say hello. Okay, Timothy. Timothy P. Here we go. Good. Okay. Oh, no, let's see. Here it is. Okay. From yesterday. I hope this looks familiar. Although I need one more thing. What am I missing from my demo from yesterday? Ingrid? A magnet. So let me get that. I've got a really big. This is called a bar magnet, by the way. There are bar magnets and horseshoe magnets that are shaped like that, like a horseshoe. Okay, so I'm not going to turn it on because there's no point. I can't hold it at the same time. So folks at home and folks here, what if well, I can make current by doing this, of course. We said that with our review of the Lorentz force up on here. What can I do to make more current or voltage, more current flowing or a higher voltage? There's 4 things I could do. Alessia, give me one.
Run the magnet against the coil faster.
Faster. Okay, so I can make this go faster, the metal through the coil, like that. Yeah, good. Give me another, Tim.
Larger, like enlarging the magnet.
I could make a greater sized magnet, so a larger magnetic field. So far I could move the magnet faster through the coil, or I could make a greater magnetic field. See if anybody's responding at home. Not yet, they're probably still typing. Zach.
You can use a coil with more loops.
Oh, okay, so I can increase the number of loops in my coil. That would do it, and I got one already. And from Kiara, she says I could move the coil faster the other way, over the magnet, and that would also work as well. Those are the 4 ways. Super. Thanks, everybody, and folks at home. So I think, can I look with you? Are we done with this station 1? Folks that are here, is that pretty much all filled in? See if you got any questions on station 1, folks here or folks at home. Alessia?
So what do you call this phenomenon? The answer would be the Lorentz force, right?
Yain, it's certainly having to do with that. You could also call it something else, though. Stella, what do we write? Yeah, I'd probably call it the generator effect, Alessia, as a real specific idea here for station 1. We definitely generated some electric current. We saw it in the voltmeter showing the voltage, so it's the generator effect. Dynamite. Okay, good. Questions from folks at home? Anything you want to ask? Is that all right? We okay on station 1? Leon? Well, let's see. The explanation was, well, the observation was what? When I move either the magnet or the coil, I get electric current, right? And the explanation, what did we say? Somebody else. What did we write for the explanation? I think we said something yesterday. I'll write it up here for station 1. What did somebody else write? Alessia, what did we say?
Okay, so we get negative voltage, because the
Keep going. Yeah, negative voltage when?
When the electrons are moving in a negative direction.
Okay.
And then when you get a positive charge from the electrons are moving in a positive direction.
Yeah, but not charge, voltage.
Positive voltage.
Okay, all right. Or we could say voltage changes from plus to minus when, and I'll go back to Liam yourself. So kind of according to Alessia, voltage changes from positive to negative or negative to positive when the electrons do what in the lead there, Liam? Yeah. And in general, Zach?
And they change direction.
Beautiful. Let's say it that way. So when they change directions. So when I go this way as an electron or this way, it matters. One way gives a positive voltage, one way gives a negative voltage. That's what I'm trying to say. Now, let's see what other folks hold on to you. Okay, Yulia says, in what field did the flowing current, magnetic field, and force things go? Well, in what field? Let me think about your question. Okay, so I guess I should say this. How about this? When we had a magnetic field, Julius, we put it through the coil, and what we created was essentially in the wire, I created movement of the electrons. So I pushed this in like so, and the electrons went like this, either back or forth when I went in or out. So I guess you could say I produced an electrical field by shoving in the magnetic field into the coil. And I made the little electrons move, which is, of course, what an electrical field is, right? Does that help you, Liz? Where should you write it? I don't know if you have to write it there. When we talked about the three fields and so on, Ulysses, I think we put that in our notes in general with the Lorentz force yesterday. So if you have that from yesterday, you already have it written down anyway. So you may be all set if you were there yesterday. Other questions, comments from folks here on station 1? And Leo. Yeah, of course. You can walk around if you wish to. Okay, then I'm going to switch to station 2 so you can look down at that one. And I'll put this here on the cart and remind myself in my box what I need for station 2. I got them all set up. So I need this. So I got another coil, and I got a loop of wire going through the middle of it. And that's not enough. I need a voltmeter on this sucker. Maybe I need the same one. I don't think so. I don't need this one. Maybe not. That should be the same one. Maybe I can use the same one. Let's see it. Hope my battery's not dead. So I got it on millivolts, like I had yesterday. And these folks at home can't see a thing. All right. Okay, hope that's a little better. So you can see the coil, and I got kind of like the picture. I got a closed loop. The coil is going over to the voltmeter. Okay. By the way, see where it says U? That's the symbol in German for voltage. So if you want to write below that a capital V, that's what we call it in English is voltage. In German, they use the letter U, and I don't know why. Okay, so you know what that is. So that's a voltmeter, and there's my coil. And now check out what we're going to do with this. We're going to take a magnet and turn it in front. And right now it's pretty close to 0, as it should be. And of course, I can't hold that up the whole time, but I will while I'm doing it. Here's what we're going to do. I'm going to pull this over a little bit so you guys can see. And I hope, oh man, now I hope my folks here can see. How can I do this? My problem is I want everybody to see. Can I lift it and do it? Not really. Could you help me, Stella? I'd like to do this so everybody can see. And I need you to hold this thing so everybody can see the reading. Maybe like there so they can see it on screen as well. Okay, and according to the picture, look at what I'm going to do. Am I putting the bar in the coil? Am I putting the bar magnet in the coil? No, I'm spinning it out front. So right now it's pretty close to 0. If I spin it out front, ooh, look at that. Whoop, that went inside. Even if I get close, I'm getting a voltage. Now I'm going to spin it the other way, right? Like this direction. And it's not a lot, but I get a voltage even if I'm not even in the field yet. Little bits of voltage if I do that, if I spin it out next to this. That kind of happens in what? That we already drew a picture of. Wait a minute, did you and I draw a picture of that already? Did we draw yet a generator? Yes, yes, no, no? No, no. Okay, so folks at home, this is kind of like what we had happening in what? In the power plant. Right? In the generator. So you guys had the generator last week. We'll write it up at some point for all of you, although more or less you know what that is now. And if I turn it, even if it's not in there, and I know you can't see it yourself, Stella, but I'm getting small amounts of voltage if I do that. If I turn it even in front of the coil of wire. And essentially that's what's happening. Jump to a coil, okay. In Berlin, we use what to make our electricity? What do they burn here in Berlin for the most part?
Like fuel.
Yeah, what fuel?
Coal.
Coal. So we burn coal. There's a machine that I haven't given you a diagram for yet. It's called a steam turbine. It spins really fast, and it's connected to a generator. And imagine then it being connected to something like this, and I'm spinning this really fast, and by golly, that's the way society gets our our power, or with our electrical current, our electricity. So that's kind of the way, is we spin something in something else. So what we're spinning either is the coil or the magnet. I can spin either one. In the coal burning power plant, we're actually spinning the coil. But it doesn't matter, as it turns out. I can even spin the magnet like I'm doing here, and I get some voltage there too. Thank you, Stella, very much. So let's read what they ask questions about. Okay, so station 2. So the observation is what? When I spin the magnet, I still get some voltage, even if the magnet's not in the coil. Good. Let's write some stuff like that, okay? All right, let me try and erase this board a little better. So it's observation. We got voltage when a magnet was spun in front of a coil. Explanation. Well, what do you think? Why is that? It must have been what? Even though it wasn't in, it must have been close enough to kind of do what? So to speak, Zach?
It was still able to move the electrons.
Good. So somehow the magnetic field was close enough to still be able to cause the electrons to move. Good way to say it there, Zach. Okay, so. Okay, so this still caused the electrons to move in the wire, even if the magnet was not in the coil itself. And I'm going to pause and let you catch up and see if I got questions or comments from my people at home as well. Yeah, coal, right? Thanks. Malta knew that as well. Good. And then from Kiar, there was a big enough magnetic field so the electrons could create electricity. Yes, exactly. So moving electrons, that's electricity. So I still could create a field. Okay, what do you call this phenomena? Actually, it's a little repetitive. What is this? What is this phenomena again? What is this, Corey? I think it is again. I didn't write up this sheet, Corey, but I think it's the same phenomena, just looking at it a little differently, isn't it? I think it's still the generator effect. Okay. I will sure move. I wish I could get you a little closer, Alessia. Alessia, you can always allow it to stand or move so you can get where you can see it too. I'm sorry you're stuck in a bad spot there.
You're in front of the board.
Right, so like that irritating teacher keeps getting in the way. I totally understand. I think it's true for my people at home too. If I stand right in the way, they can't see anything. Let's see if they got anything else they need to ask about. Okay, and I think I've got Michael there as well. So Michael has joined us also. Michael, you'll have to watch the video though. You missed most of class, right? So that's more than 2/3 of class. So I can't really give you credit for coming that late. You missed a lot of goodies. Okay, now to the last part of station 2. So if you look down there, are we about there? Okay, what forms of energy are converted? Now, some of this I hope you got in another class. Let's find out. If I have something physically moving, like that guy moving, rotating, what kind of energy is that? How about Liam? Let's see if you had that in another class. If I got something moving like that, what sort of energy is that? You might have had that word, I hope, in another class. Tim, have you had that?
Physical.
No, it's got another word, Liam. Kinetic energy. Does that ring a bell with others, that word now? Okay, if you haven't had it, let's write it so you know how to spell it. So it's kinetic. And in terms of what that is, if you haven't had it before, it's energy of motion. It means something's got to be moving like the coil. Okay? Kinetic energy, energy of motion. In German, kinetische Energie. So it's pretty much the same thing. Okay? Easy to recognize if you have it in German next year. Kinetic energy. Okay, then it's being transformed to what? So, and I did that. What did it create, so to speak, Tim? Yeah, why don't we call it, can we call it electrical energy? Okay, electricity. So, okay, so,
Oh, so which one?
hold on, you're right with you, Alessia. So electrical energy. Alessia.
Bringing up this these lamps, right, are giving off electrical energy.
Say that one more time.
These lamps over here, they're giving off electrical energy.
Absolutely. So even though we don't think about it, and you and I, did we talk about that in chemistry? How light, we get light from mass? Yes, no? Okay. All right. Maybe last year, Okay, I think you're right. Anyway, So what's happening is electrons flow through the lamp and they flow back and forth. Folks in my other section had this, they alternate. So they go bump, 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 bump. And as the electrons flow, they excite the atoms, and the atoms start to have electrons moving back and forth, and they give off light. And what those are filled with is just air. Some are filled with different gases. If you've been downtown and seen like red advertising, it's filled with neon. They're called neon lights. But it's the same thing. I give energy in, and the electrons then get excited and give off light. That's how we get light. But it has to do with flowing electrons. Here, if I say electrical energy, what I got from Tim, what I really need is flowing or moving electrons, like in a wire, in this case. Corey?
Would this be considered magnetic energy as well? Or how does magnetic energy work?
That's a good question. There is really no such thing as magnetic energy. There's a magnetic field. And using a magnetic field, I can help to get one type of energy or another, but magnetism itself is not really an energy. It's more or less, it's a field, Corey, which can cause a force. Like, even if I have, I don't know if I can do it. Okay. This we had last time, I think, folks at home too, right? Yeah, let's call mechanical energy the same thing, Michael. Let's call that kinetic. Yeah, exactly. All right. So if I keep my magnet away, that's kind of stupid. If I keep that away, then I could say, okay, this is lining itself up, Corey, with the. Exactly. So that provides a force which causes this little pointer here to move and align itself with that field. So it's not a source of energy, but more like a push or pull. So I would probably call magnetism a force. Yeah. Good. Any other questions, comments from folks at home or folks here? Are we good on station 2? Yes, we are. Okay, so let's put this aside. And we're going to get another part out. Yeah, we might be able to get this to be started. Okay, we're going to put that down here. Okay. I got a big box of tricks today, don't I? Okay, so I've got to show folks at home this. I got to show you here too. I'm going to show folks at home, and then I'm going to show you. I'd like to get this around where it's a little more straight. Okay, so I got a couple of leads. I got one going into this device and one going out the other side. And I've got something I can turn. So physically, I'm going to use, again, kinetic energy, aren't I? I'm going to put in some turning. And I got this, which probably folks at home can see as well. That's essentially my what? This sucker right here. Tim, that's going to be my coil, all right? And notice the coil is on an axle, right? Like a car axle. So if it can do that, can you guess what's on either side of that coil? So to make all this happen, Claire, if that's the coil turning, probably what's this here on either side of it? Yeah, I bet it's a magnetic field, okay? So that's probably a magnet. Good. I'm going to show this to folks here, so I'll be right back, folks at home. But I want to show it to you up close so you see some of the parts, okay? So, and that's what we're going to turn at the other end. And that's just a bolt here. Okay. I'm doing this because, frankly, most years I can have students do it yourself, but this year I don't have that opportunity because we're not in a science lab, so I'm not allowed to do it. I wish I could. Well, There's another term where you put a wire inside that, do something to it. But I don't think it's anything other than these parts. Well, no, I wish I knew. It's the only thing I use the bottle for each year. So there's my axle, there's my coil here, and then I just here, and then here. I'm gonna crank that coil with this. Okay, I'll show you all right. Okay, so here we go. Ah! Just pulled it apart. I'm going to do this twice. I'm going to do it once here for folks at home, and I'm going to do it once for the folks here because I'm going to block, of course, everybody here. Now look close, folks at home, at the voltage here. I got it on 3 volts. I wish I could have it on millivolts, but this doesn't go that low. So all I can do is crank it like this. Come on. I need a really flat surface, and I don't have one. And I hope you can see the arrow moving a little bit as I do this. It's not a lot, but it should see some little movement back and forth of the arrow. In fact, I'm going to switch these suckers. Because I think a lot of the voltage is on the negative side right now. Let's see if I can get it on the positive side. Yeah, there you go. Okay, so hope you can see the little arrow over here moving when I do that. Oh, doggone it. Look at that. The plastic came off here. I hate it when that happens. It's never happened before, and I hate it. Okay, come on, puppy. Get back on there. Okay, folks here. So, I'm going to turn this thing, and that's going to turn the axle. It's connected to the axle. And it's not a lot of movement, so I hope you look close here, and I hope you can see the little arrow going. And again, now I'm going to, oh, what if I go the other way? Then it's more on the positive side, isn't it? Okay, so that's my deal. Now, do that. Just not enough. Okay, so there I'm going one way and it's negative voltage. If I go the other way, I'm making a positive voltage. Okay. All right. Folks at home, what is this and where do I find it? What is this and where do I find it? You had this already, but the people here in this classroom have not had it yet. Can you guess what this is? And what would this axle be connected to? What would that axle, that turning thing, would be connected to what? You got it. Yes, Kiara. And now somebody else, what would this be connected to? That's gonna be connected to what in a power plant? Yeah, right, Linus, it's a generator, and yeah, good, Malta, it's gonna be connected to a steam turbine. So, for my group here, when we get to talking about a power plant, I knew that would happen. But we've done pretty well. So this is an actual generator, and I generated electricity with it. And Tim.
Well, how does the steam turbine turn?
Okay, a steam turbine, the main thing it does is I put hot steam in it, and as the hot steam goes through, it's under such pressure, it kind of releases that pressure and expands, and it makes these little paddles spin really fast. And it spins, and it's connected to this, and then this thing spins just as fast. But we'll try and go into that in more detail, Tim. Remind me, because if I got 2 sections of 9F and 2 of 9E, sometimes I forget stuff. But I want you to know that, because the steam turbine's pretty cool. Okay, thanks everybody at home. Bye. Bye. Thanks everybody here too. Bye-bye. See some of you next week at home. See you guys in 2 weeks.